So I have been working on a plan to convert this bike dynamo that has like a AC lighting system over to a DC system that will run some LEDs. So I found an interesting design by a guy in the Netherlands for doing the conversion, taking the 6-volt AC that this generates and turning it into essentially 5 volts DC. So I thought that sounded pretty fun. So this is the circuit. I have it about half built, and it was just from a bunch of random components I was able to salvage from different electronics around here. So I've got sort of a hodgepodge of stuff that I've pulled out of different power supplies and random things. For example, you might have something like this sitting around your house. So I cracked something like this open, and inside you find a very similar circuit every time. There's usually some sort of bridge, diode bridge in here, and then some integrated circuits, maybe a transformer sometimes. So you can see in some of these there was a little transformer as well to do some of the voltage conversions. One about this size is probably all solid state. I don't think there's probably a transformer in there, but this is one of my nicer ones. And it worked fine, so I wasn't taking it apart. But anyway, so one of the things that I salvaged out of one of these power supplies was this little guy here, which is a nice little diode bridge. So what they do is it'll take the 2 AC signals in and uses I think it's called a Wheatstone bridge, which is a set of diodes in a square arrangement to take AC and convert it into DC. Now it's really messy DC, so it's not something you want to try and pipe into electronics or even lights. But that's what these guys do, is these guys help clean it up. So this is a 100 microfarad electrolytic capacitor. This is a 0.01 microfarad ceramic capacitor. And this is a big 2200 microfarad 25 volt electrolytic capacitor. And then there's a little diode, little Schottky diode down here that does some forward rectification as well. The main idea behind these 3 capacitors is they cut down on the amount of noise because they're across the circuit, right? So across the DC circuit, if any AC variance makes it through, or there's a variance in the DC, what that does is it helps remove that noise from the DC line, because when the power is high, there's a spike, it charges the capacitor, and when there is a low voltage, the capacitor discharges, and so it evens out the voltage a little bit to make it a more consistent signal. This guy here acts as just a giant voltage dump, or giant current dump, so it just sucks up basically all the power and stores it here, and it'll hold about 20 volts or so of power, and it holds a ton of it, right? So and then that goes into the diode and out the other side. So what would be on here that's missing is a 7805 voltage regulator that'll take all of this voltage that's over here and turn it into a consistent 5 volt power supply. And then this diode here is going to keep that reverse current from leaking back into the rest of this circuit. So what's fun is I rigged up this little thing to my drill. This is just a wheel from an RC car, and I'm going to use it to drive this dynamo to charge up this circuit and show you what it looks like. So over here, you can see we have a little bit of charge in here. So there's some amount of charge that has been accumulating in this capacitor just from the test that I've got, the fact that I'm looking at the voltage on this circuit. but I've got the positive lead attached to the positive side of this capacitor. I've got the negative side attached to the negative in here. And what we're going to do is when you see me charge this dynamo, keep an eye on this here, and you should see it go up as it's storing the voltage in the circuit. So let's see if we can get this charged up real quick. All right, and so now you can see that that went up pretty high on there. So if we want to see how much we've got, how many volts we've got in here, you can keep a look at this guy. And let's see if I can measure this and show this at the same time. I think you can see that, yep. All right, so we're just gonna measure voltage across the capacitor here. It's electrolytic, so we need to make sure that the positive is to the positive, negative is to the negative. And you can see we've got about 14.7 volts sitting in there, and the more we sit on it, the voltage starts to drop. So it's discharging as we measure it, which is what you'd expect to see. And so this is holding a bunch of electricity right now. And then what's kind of fun is discharging it. So we're taking an insulated pliers, and if we do this, you can see it discharge, and if you were watching the meter, you could see it go down. So that's after we discharge the unit, and then we can charge it back up again. So if we run the drill, and you can see it charges up, and it charges up pretty fast. So anyway, this is about half the circuit that's built. The other half is the 7805, which hasn't come yet. I didn't have any on hand. I was hoping to find one in one of these power supplies, but no such luck. So I need one of those, so I ordered one. And the other thing is a 1 farad 5 volt cell. So the 5 volts that comes out of the 7805 voltage regulator is going to go into a 5 volt 1 farad capacitor, basically, that acts like a short-term battery. It actually looks like well, it looks like this. So it's about the same height as 2 of these little 2032 batteries stacked together. And you might say to yourself, well, why don't you use batteries? And the answer is, you could if they were rechargeable, but even that doesn't charge up as quickly as a capacitor. So this acts as a temporary power source, basically, for the lights. So as this is running on the back wheel of the bike, it's charging up the circuit, but also keeping the lights lit. And then when I stop at a stoplight or stop sign or something, this stops running, and slowly the capacitor will decharge, but it'll keep the lights lit, and it'll probably keep the lights lit for a good couple of minutes because of how much electricity it's stored. So this acts as a nice little non-battery powered reproducible light system that's all DC based, but uses an AC dynamo to charge the whole thing. So it's a pretty cool circuit. Anyway, big thanks to the guy in the Netherlands, I can't think of his name now, who came up with this circuit idea. And I've just adapted it to components that I had on hand. So pretty fun. So we'll finish breadboarding it out, make sure the circuit works as we expect it to, and then I'll actually put it onto a circuit board, which I'll probably do in a subsequent video. So anyway, hope you enjoyed this.